Hello everyone. It is Business Data Communication course, and it is Chapter 1 Introduction. And the textbook we use is Computer Networking, a top-down approach written by Cross and Rose. And Chapter 1 is very simple and general introduction to the entire computer networks, including the software, the network protocol, the hardware, and device and links. A lot of things in this chapter. So we will go over the first chapter, and we would further dig into different details in the later chapters. Okay. First, the goal of chapter 1 is to get feel and give you a very nice and big picture of the modern computer network. So basically, you have to understand some and learn some terminology, and it makes you more easier for you to discuss or talk about different technology in the computer networks. So make sure you understand those terminologies in chapter 1 so that more depth and detail will be discussed in the later chapters. And the reason why we need to let you get familiar with those terminology is because, for example, when you write your homework or you take your exam, you have to use those specific terminologies in your essay, so that TA or me or your lecturer knows you really understand what exactly those terminology means, and how and if you could correctly use those terminology in the right place, so that it makes you frankly speaking, it can get higher grade, right? Higher score. And here's the overview and roadmap of the first chapter. So we will go over all these six sections. The first one is what is internet, and make sure you understand this specific word, internet. Okay, that is capital I. So it is not just a general term. It is exactly the computer networks we are currently using here right now. Okay, and that is because in the early days there are a lot of different computer networks, and the current internet is just one of those old networks. And of course, because we different users, different devices, they indeed need to connect with each other. So gradually, some old network fails, and the network we use right now, which is internet, and wins. So make sure you understand that the internet, this specific word vocabulary, is the word that we described the current network we use. Okay, and we'll talk about what is protocol, network protocol. And basically, protocol is some kind of rules that specify or define how devices or programs communicate with each other. There's some rules, and we'll talk about protocols, a lot of protocols in chapter 2. And we have network edge, which means those devices host and physical media, and access network, which means how do we connect it to the entire internet. We'll talk about how what kind of devices, what kind of physical media we use. The third one is network core. That means there are some other devices which is far away from us, and they are in the cloud, they are in the internet. So there are some specific technologies and protocols that is used by those devices, which is far away from us. So basically, for example, iPad or your cell phone or your laptop, your PC, which is the devices you can touch, right? which is nearby you. So those devices are network edge. But there are some devices which is, for example, routers. They connect different devices, different network together, and those routers are not what you can touch, right? So basically, we can use these simple rules to specify devices of network edge and devices of network core. Okay, and of course there are some performance issues that different types of medias, different types of communication protocols, different types of communication structure, they have different performance. It means we have different loss rate. It is not necessary to, for example, there's some different network architecture. So some architecture, they guarantee your message will not be lost. Some architecture guarantee your packet will be delivered successfully without any loss. But some architecture, indeed, they do lose your packet, lose your message. Okay, and there are some different requirement of application. For example, when you watch a YouTube, and maybe maybe it is very sensitive for you to require a network application that has very little delay, right? But for some application, for example, receiving or sending an email, it is not. It really doesn't matter what is the delay when you receive a message. 1 second, 2 second delay, which is okay, but in a video, in a online streaming video, 1 second delay or 2 second delay is sometimes not tolerable. Okay, and third part is the performance of the network. Okay, so and we will talk about what is protocol layers and what is service model. Command network is a very complex technology. It includes several different technologies. For example, software engineering, hardware engineering, software hardware design, material, and protocol, operating system, something like that. So since it's very complex, so we divided the entire network into different functionality, and they are layered. So different layer responsible for different, of course, functionality. So some functionality is implemented by, for example, EE students, EE researchers, and some functionality is implemented by, for example, computer science expert, and some application, okay, is implemented by, for example, MIS students or expert. So different expertise will focus on different layers, and they all together come up to build up the entire command networks. And at last, we have we will talk about a story about command network history. So basically, when we talk about internet, there are several different components. So the first one is the billions of connected computer devices. Okay, devices or host or end system. Okay, there's several different terminology, but they all have same meanings. That means the devices you use. For example, the laptop, the smart refrigerator, the server, your smart car, your cell phone, your laptop. All of them are devices, no matter how they looks like. The other devices you can use, you can connect those devices to the entire internet. Okay. So the second thing is the third one, which is the communication links. Those devices has a need, a communication link, so they can attach to the network, right? So there are several different types of communication links. For example, fiber, copper, radio, satellite. No matter if it's a wireless link or it is a wired link, as long as you can, your device can attach to the network, the computer network, it must use certain type of communication links. Okay, and one of the most important thing about communication link is its transmission rate, right? So or we say bandwidth. The unit is bit per second, bps. That means how fast you can push a bit from one device to another device via such kind of communication links. So generally speaking, in modern network, usually the communication links should be something like 100 megabit per second to 1 gigabit per second, something like that. We will talk about the characteristic of different communication links and their capability to transmit messages in the later chapters. Okay, so at least you should have one of the communication links to connect to the other device. Okay, so when you have a several device and you have communication links to link them together, you can build a network. Okay, which is the blue area in this slide. So for example, in your home network, okay, you can use Wi-Fi or some Ethernet to connect all your devices together and form a home network. Or for example, in your in your company or organization, you can use certain devices, okay, right here, to link all the routers, all the PCs, all the laptops, all the servers together to form an enterprise network. So, but there is another important thing is that once you have those small network, how those small networks connect to each other and form an even bigger network, and so on and so forth, so on and so forth, and at last we have internet. So there's an important terminology or concept right here is that there is always a link, okay, which connect your small network to some other bigger network. And the link right here, okay, is what we call last mile. Okay, usually there is a role called Internet Service Provider, ISP. For example, AT&T, T-Mobile, or HiNet in Taiwan. There's some other ISP, Internet Service Provider. Okay, they provide such kind of last mile service. Okay, so for example, in your home, maybe you can subscribe. Maybe you have heard of those terminology like DSL or cable. Okay, there are some service provider. Okay, they can attach your home network to the entire internet. Okay, so you subscribe DSL services or cable services, and they will give you some equipment so that your home network can attach to the entire internet. Okay, of course there are some different technology that can help you to your small network to be attached to the internet. But in this textbook, we will talk about DSL and cable. These two different technologies. How can we attached to the internet. Okay. So and of course, in the internet, there are some other devices, which is right here, called routers or routers, okay, and switches, okay. Routers is something like this one, and switch is a square with a X, okay. Those devices are used to connect different devices or networks, and we will talk about what is the difference between routers and the switch in the later chapter. Okay, and we will talk about packet switch this specific let me say technology or some or a technique later. Okay, because I think it is too early to explain what is packet switch right now. So that is how our internet has been built. Okay, we have some small network, and those small networks connect with each other by using the last mile and some routers and switches, and together of them, okay, to form the internet. Okay, that is the component of the internet. And sometimes we use a phrase, network of networks, to describe the internet, because it has several interconnected ISP, internet service providers, right? And of course, ISP has several different technology to connect everybody else. So, for example, you have a 4G, 5G network. We have cable network. We have fiber network. Have this DSL network. Okay, but all of those networks eventually will be connected together to become the internet. Okay. So the next concept is protocol. Okay, as I mentioned before, it is something like rules to that different devices that they can communicate with each other. Okay, so who define those rules? Okay, here we have organization called IETF, Internet Engineering Task Force. That is an organization that academic people, industry, and government, they were trying to figure out what kind of network technology should be in the future. For example, we have 5G, the fifth generation cell phone right now. But actually, governments and those organizations already define what sixth generation cell phone should be, and further, the seventh generations 7G, and different organizations will submit their RFC document to the ITF. So every standard are public available to everyone. So you can write your comments on those RFC document, and they will try to figure out what is the best definition, what is the best, the most practical way to build a 6G or 7G network. So that is how it works. And of course, to define or to write a protocol, it takes a long time to write down every rules. So it may take, I think, 5 years or even more years to define the next generation of network protocol. Okay, so let's think about some example in the real life. For example, if we have two ships, okay, in the ocean, before we have those modern communication technologies, how do these two ships to communicate with each other? So I think the one of the way is that two soldiers, okay, they use some flags with different colors, okay. So if they wave those flags in different ways, so that the other soldier on the other ship, okay, when they see those different colors, different shapes of flags, so they can understand, okay, that ship want to communicate with me, and they what is the definition of that color of the flags. So basically, those two soldiers, they should have for example, a book, okay. This book specify every color, every shape of the flag, so that everyone understand what is the definition of those different types, different colors of flags, so that they know what message they would like to deliver to all the other ships. So basically, those small books, those books are protocol. Okay, someone need to write down every rules on that book, and everyone who want to communicate with each other need to read that book and implement that by using the flags, right? So I think that is one of the example that very similar to what protocol is. And another example is that in ancient China, because there are some barbarian would like to invade the empire, so they build several castle along with the Great Wall, right? So every time when some soldier, they observed the barbarian, and they may light some fire on the top of the castle. So some other castle, when they see that light, they know, okay, there's something wrong with the border. So we'll light their castle again and again and again. So this message can be transmitted from the border to the capital in a very short period of time. So that is some kind of protocol that means if there's nothing wrong with the border, so just don't light the fire. But if there's something wrong, barbarian is coming, so you light the fire, right? So everyone, when they see the fire, they light their fire again, and so on and so forth, so on and so forth. So at the end of the Great War, the soldier, when he or she observe, okay, I saw the fire, and they may report such kind of message to the empire, to their to the capital. So that is one of the example of a protocol. That means everyone knows that. So they can communicate with each other by using the predefined protocols. They know what kind of messages should be delivered from one side to the other side. Okay. So before we continue, let's take a look at the ARPANET, okay, which is the I think it's an important thing that you have to know. That let's take a look at the picture at the right hand side. It says the ARPANET in December 1969. Okay, make sure you understand that 1969, that is the year that human beings went to the moon. Okay, so and that year, okay, 1969, there are four university, okay, UCLA, UCSB, Stanford, Utah. They they are trying to because they have several valuable messages, they have some research messages, would like to share with each other. So they built the very first internet, and at that time we called it ARPANET. Okay, there are only 4 small networks connected with each other, and you can see that UCLA, SRI, and UCSB, they are university in California, so they can they have 3 I think the cables, 3 cables that can connect them together. But Utah is a little bit far away, so they only build 1 cables between Utah and SRI, Stanford. So because I think that is the limitation of funding, so Utah only has 1 cable, right? So in that way, they can exchange messages, exchange information, files, or some valuable information. So after 1969, okay, take a look at this picture. Lots of university, they may find that having networks, okay, is very useful. So lots of university join ARPANET, and they create they have, each network has each university create its own small network, and they use those cables to connect all those small networks together. Okay, and as you can see, for example, it is not necessary to have direct cables in between every pair of the university, right? So if Utah would like to send a message to UCLA, and it can send a message to SRI, and using some technology, using some algorithm to redirect, or we say forward, or say relay those messages to UCLA. So it is okay that Utah does not have a direct connection between Utah and
UCLA.
Okay, so that is the same. Okay, the east side and the west side. You can see that they have only 3 long distance links between the east side and the west side, right? But it is okay because those intermediate, we say node, or say relay node, or call those university can help others to relay the messages or information, right? Okay, so that is the ARPANET. So very similar. So let's take a look at the picture at the right hand side. So that is the reason why we have so many routers in the internet. Okay, because those routers are very similar. They helps all the small networks to connect with each other. Sometimes direct links is not available, or they do not build direct link, but those routers, they are connected with each other, so they can help you to relay your messages from your home network to someplace far away. So that, I think that is the reason why we take such kind of strategy, because it is cheaper, and it is more high performance to build such kind of network of networks. If everyone in this figure needs to build a direct link with each other, it needs a lot of communication links, and it wastes a lot of money. Okay, so network of network, and they are connected by routers, which is more efficient design. Okay, So again, let's take a look at a very interesting figure, and this figure is the Taiwanese ISP. Okay, the gray blocks in this picture, okay, is the Tier 1 and Tier 2 ISP in Taiwan, and the blue blocks, there are 4 blue blocks, they are exchange center, okay, and the green ones are academic institution, and the right hand side, those are different countries. So the difference between Tier 1 and Tier 2 ISP is that in Taiwan, Tier 1 ISP can build their own last mile. Okay, for example, they can deploy phone line from their center, from their telecom center to your household. Okay, they can build the wireless 4G, 5G station, but the second tier ISP in Taiwan cannot do so. So they just simply rent or buy services from the Tier 1 we say ISP. Okay, so let's take a look at one of the biggest ISP in Taiwan, which is HiNet. So we can see that this ISP need to connect to other ISP. So that is how internet has been built. Different ISP connected with each other. So the customer of this ISP can reach the entire internet by through the ISPs and the red links right here to other ISPs. Okay, let's take a look at the one of the link is that the HiNet to United States, which is the yellow color at the right hand side, the bottom one. Okay, it says HiNet built some has a direct link to United States, and of course the United States is just the country name. Basically, HiNet build those communication links with the ISPs in United States. Okay, the total bandwidth is 153.788 megabit per second. This is a very large communication link. Of course, there are some undersea cable fibers cables. Okay, the total capacity of those cables, those fibers is this number, so that the customer in HiNet, okay, can reach a server in United States by using those links. That is because the HiNet spend a lot of money and build those cables, those fibers through the ocean to the United States. And of course, in Taiwan Island, for example, the HiNet and let's see, we have another one. It is called T-Star. Okay, T-Star. Okay, the HiNet has several links, and the total links to T-Star is 30,000 megabit per second. T-Star is one of the biggest cell phone, cellular service company in Taiwan. So for the users in T-Star, when they use their mobile phone to, for example, to download something from HiNet or HiNet's customer, they will go through this specific line, which in total 30,000 megabit per second. Okay, and of course there are some other entities. For example, TANET. TANET is the Taiwan Academic Network, and it's all the university, public university, and high school and elementary school are connected to the HiNet, and HiNet will further connected to some commercial ISPs such as HiNet or EBT, FTN, which is Taiwan Fixed Net, or CNS KBT, it is cable ISP, something like that. So that by using those links, different ISPs connected with each other and form the internet, right? And for those blue blocks, they are exchange center. They are companies. I think that their owner are ISPs, so they will build up several exchange center, and some small ISPs can pay some money and connect to the exchange center, and exchange center will have lots of links right here to connect everyone with each other. Okay, Taiwan has 4 major exchange center. Okay, so I think it is it is very interesting figure that you can sometimes when you choose an ISP, if you move to a new house and you want to subscribe ISP service, and you can take a look at this figure, and different ISPs invest a different amount of money to buy this to build or buy this bandwidth and connect it to other ISPs, and I think it's very interesting things. Okay. So as I mentioned, in internet, a computer network, it is a very complex concept. We have different technology, software, hardware, protocol, material, links, and because it is too complex, so as a very important infrastructure, and for frankly speaking, for a general user, they don't have to understand what is the underlying detailed technologies or algorithms or IC chip used, right? Just like water or electricity, we don't, as a general user, we don't have to know how electricity is generated by wind or by nuclear power or by water, right? So as long as I have an electricity plug on the wall, I can use whatever device, right? Your TV, your computer, as long as you plug to the plugs, and it works, your device, right? So you don't have to understand what is the underlying of technologies, how those electricity are built. Just like for another example is water. We don't have to know how water is cleaned. As long as we turn on the tap and the water is ready for you to use, you can cook, you can drink waters, you can do whatever you want. So it is very similar to computer network. Once you have once your ISP help you to connect your home network to the entire internet, you don't have to understand how different layers of technology used in computer network. But I think that as a general, users don't have to know that. But as an MI student, you have to know all this along the line technology. So it's very similar to programming computer networks is layered. We will talk about why and how those layered function. But it's very like programming interface, or we call API, application programming interface. That means for each layer, okay, it has certain interface that you can interact with the upper layer and the lower layer. Okay, so when you write a network-based application, you don't have to know how a bit is transmitted in Wi-Fi, because there's always a function call or API that you simply just send your message through this API, and this API will function correctly and help you to send your message through the wireline or through the wireless Wi-Fi, something like that. So every layer of the computer network is clearly defined. We'll talk about this service layered things in the later chapter if you cannot comprehend what I'm talking about right here. But it's okay, because it's very complex to explain this concept without any prior knowledge. But we'll talk about those things in the later chapter.